Hi, my name is Mohamed Ghazy. I obtained my PhD from Purdue University, United States. And during my career, I was involved heavily in tutoring high school students and university students in math, physics, and engineering subjects. And really, I have a passion for tutoring a long time ago. The student that they have problem, they feel really understand the material. That's the most important thing. Not just, do the homework and the assignment. Just, I want them to understand it, love it, because once you love it, you never get bored and you never feel the pressure. Okay, so now let me show you a short demonstration for a simple topic in physics. This topic is called velocity time. Okay, let's start demonstrating the velocity time graph and how can we solve the problem. The aim of this demonstration is to calculate the acceleration and the distance traveled by the car. Let's assume now that the car started with a speed equal to 10 meters per second. And the driver started to push in the gas, so he's speeding up. So after 10 seconds, the speed of the car reached 40 meters per second. The question now, we want to find the acceleration. We write acceleration by the letter A. So we'll say A is the acceleration. How we calculate the acceleration? First, we have to understand the meaning of acceleration. The acceleration, it means the rate of a change of the velocity. It means how much the speed or the velocity is it changing per second. Well, to visualize the problem, let's represent it on the graph. We call this graph velocity time graph, where x-axis is the time and the y-axis is the velocity. We'll start with the first condition. The initial velocity of the car was 10 meters per second. We'll assume the t at this time is equal to 0. So at 0, the speed is equal to 10. So we say this is 10 meters per second. We'll put circle here. That's the initial velocity, VI, that we just represented. And then after 10 seconds, so let's calculate this, assume every square 2 seconds, 2, 4, 6, 8, 10. So after 10 seconds, the speed of the car, 40 meters per second. So that's 10, 20, 30, 40. We put the point here. That's the final point. So if this is the initial, this is the final when the velocity is equal 40. And then we connect the 2 points. So this straight line represents the relation between the velocity of the car with respect to time. Now, how can you find the acceleration? We find the acceleration, as we said, the rate of change of the velocity with respect to time. The velocity change. How can you calculate the change in the velocity? You go for the final stage. The final stage, the velocity is Vf. And the initial Vi. We divide it by the time. In this example, the final velocity is equal 40 meters per second, and the initial velocity is equal 10 meters per second. And the car took 10 seconds to change the speed from 10 to 40. So remember, always put the final minus the initial. So what's 40 minus 10? It's equal 30, and divided by 10 seconds. It's better to use the units. That's 30 meters per second. Why? It's the difference between two velocities. And the unit of the time is second. So now we have 30 over 10 is equal 3 meter per second, meter per second square. So the acceleration is equal to 3 meter per second square. Can we get this value using the graph? Of course. We look at the graph here. The velocity is it changing along this straight line. The acceleration is equal to the slope of the straight line. How can you find the slope of straight line? You did that in math before. Okay? In math, you make complete the triangle here.
what you call this, if you remember? This is the rise, this is the run. And the slope of this straight line is equal the rise over the run. The rise, it's actually the change of the velocity. Yes, because I mean, here you have that is the vertical line. The vertical line, the difference between this and this, that would the final speed 40, when you go this 40, and that's the 10, and the difference is equal 30. So the rise is equal 30. And this one is equal 10, the time difference. So the slope in this case is equal 30 over 10. Let's change the color so you can see. So the slope is equal to 30 over 10, which is equal 3 meters per second square again. So it's very important that we understand this point, that how can you find the acceleration from the graph, and you can find it mathematically by this equation of the acceleration. Okay, as I would like to remind you that we want to learn how to calculate the acceleration and the distance traveled by the car. Now let's go for calculation of distance. I will sketch the same graph. If you remember, that was 10, and then go after 10 seconds, that's 0, 2, 4, 6, 8, 10 seconds, 10, 20, 30, 40. That's 40. So we connect. This is our velocity time graph. And the question is, we need to find the distance from this graph. Okay, the distance, to calculate the distance traveled by the car, it's equal the area under the velocity time graph. In our case, it's a straight line. So to find the distance traveled by the car from the initial position to the final position, just try to find the area under the straight line. Why? Because the straight line represents the relation between the velocity and the time. So we need to find this area. And this area will be equal to the distance. There are many ways to find the area. When you look at it, let me just make it here in a nice way. So you got here the long base, and you got here short base. They are parallel because this is in y-axis. The length of this one is equal 10, and the length of this one is equal 40. You don't know the length of this one, but we know the length of this one is equal 10. So when you look at this shape, what do you think? It looks like trapezium. Okay, how to find the area of the trapezium? I give you here the rule that you got in math course before, just to remind you. Trapezium, it has two parallel bases, the short one and the long one. The short one called B, the long one called A, and the height is the vertical distance between the two bases. We call it H. The area of trapezium is equal the average base, means A plus B over 2 times the height here. In our example, you will let me just write the rule. The area of the trapezium is equal A plus B over 2 times H, the height. A is the long base, which is equal to 40, right? So that's our A. And that is our B, the short base, and that's our height. It's perpendicular, okay? So when you substitute, A is equal to 40, and B is equal to 10 over 2, multiplied by H, the height is equal to 10. So you have 40 and 10 is equal 50. 50 over 2 times 10, it's equal 500 over 2, 250, and the unit meter. So the distance traveled by the car, 250 meters. So we solve the problem. So now we know how to calculate the acceleration and the distance. The acceleration equal the change of the velocity over time, and distance is equal the area under the velocity time curve. Okay, Let's take another case. It will be easy for you now to solve this one. Okay, now when you look at this problem, that's the initial velocity, and this is the final velocity, and this is the time taken by the car. So I'd like to sketch it. When at time equals 0, when the initial velocity was 40. 10, 20, 30, 40. That's 40 at 0. And after 10 seconds, say that 2, 4, 6, 8, 10 seconds, the velocity, the final velocity equal 10, just the first square. And then you connect. That's our velocity time curve. It's a straight line. Okay, remember, the acceleration can be found by algebraic equation and by using the graph. Let's first get it by the equation. It's the change of the velocity over the time. And the change of velocity, the final minus initial, the last thing, okay? What's the final? It's 10 meters per second. 10 minus. What's the initial? 40 meters per second minus 40. Divided by the time taken by the car, 10. So when you calculate that, 10 minus 40 is equal negative 30 over 10. So the acceleration is equal minus 3 meters per second square. Minus 3 meters per second square. What do you observe here? The acceleration is negative. Why? It's very obvious, because the speed is decreasing. It means that the driver hit the brake, okay? So the speed is decreasing every time by minus 3. It means it was 40 meters per second, so the first second will be minus 3. Subtract 40 minus 3. And then after that, another 3, another 3. So that's why it's negative, because slowing down. If you go to the graph, the straight line here, you try to find the slope of the straight line. What do you observe? Oh, okay. You observe that the slope of this straight line is negative. Okay, it's going from up down. You are going down. Okay. The other case, when the acceleration was positive, was going from down up. So that's the mean negative acceleration. And when you look at it, this is equal 30. The difference between 40 and 10 is 30, and this is 10. Okay. But it's negative, so it's equal minus 3 meters per second squared, the acceleration. I want to remind you by something very important. If you are asking the question, find the acceleration, you have to write it minus 3. So you write acceleration is equal to minus 3 meters per second squared. But if you are asked, find the deceleration, don't write the negative sign. Write 3 without the sign. Why? Because already the word deceleration, it's embedded inside the meaning of it that it's decreasing. So you cannot put negative decreasing, okay? So you have to be careful about this point. Now we'll move and find the distance. The distance will be very similar to the other one because it's the same trapezoid. This is equal 30, 10, 10, and you connect. The same, the area equal 30 plus 10 over 2 times height 10. You'll find the same answer, 250 meters, which is equal the distance. So we did the problem in this case. So now we have two situations, two scenarios. Acceleration, when the speed is increasing, the acceleration will be positive. And deceleration is going to be negative because the speed is decreasing. But for the distance, the same thing. It doesn't matter you are speeding or not speeding, you still drive the car, you still distant, you are going to take it. Okay, let's look for the last case. What's the last case that we are going to see it now? Okay. The initial speed of the car is 40 meters per second. And the final is 40 meters per second. Let's sketch it so we can have feeling for it. The starting when t equals 0, the velocity of the car is equal 40. 1, 2, 3, 4, that's 40 And after 10 seconds, 2 seconds, 4, 6, 8, 9, that's 10 seconds. The final velocity is 40. 1, 2, 3, 4, that's 40. So when you connect it, you get this straight line. What do you observe here? We observe here that the slope of the straight line is equal 0. Why is equal 0? Because there is no change in the y-axis. There is no change in the velocity. The deviation is equal 0. It is parallel to the x-axis, so the slope is equal 0. What does it mean? Okay, let's write the equation. The acceleration is equal the change of the velocity over the time. What's the change of the velocity? The final first, 40, minus the initial velocity, which is equal 40 also, divided by the time 10, will be equal 0 over 10. What is 0 over 10? 0 divided by any number is equal 0 meter per second square. So the acceleration is equal 0. What does mean acceleration equal 0? It means that the speed is constant, is not speeding, it's not slowing down. So the acceleration is 0. We call that this car is driving by constant velocity. The constant velocity. What about the distance? Of course there is a distance, but this is very simple. The area under the curve. When you make it like that, it will be like a rectangle. That's the length equal to this one, which is 10 seconds. So you have this 10, you have this 10. 40, 40. So the area is equal to 10 times 40, 400 meters. So the distance traveled by the car is equal to 400 meters. Okay, so that's the three basic motion in an object used with the velocity time graph. I will leave you with this problem as exercise to solve it, but I will just give you a hint. In this one, the car is speeding up, accelerating, then with constant velocity, and then deceleration. That will be easy to solve it. Very direct application. I'm not going to make it long lesson for you, but I'm telling you there are many interesting things that we should learn. For example, what we are going to do if the velocity is not straight line, if the relation between the velocity and the time not straight line, if it's like curve, how you solve it, how you find the acceleration. There are other advanced techniques to find that. Okay, another situation here. What happens when the velocity get negative? It get below the time axis. It's negative value. What does it mean? The velocity is negative. Okay. Also, are going to learn. When you have velocity negative, it means that the car is turning the other direction. And also, there are other graphs. We just learn velocity time graph, but there is position time graph. There is acceleration time graph. There are other graphs that will be in the future when we have a chance. And thank you for listening to me.
Thank you for watching the video. I hope you enjoy it. Please, if you have any questions or you like to contact us, please visit our website www.classrx.com or drop us a line at hello@classrx.com, mentioning my name and subject line. I'm looking forward to hearing from you. Enjoy your day. Bye.